All right, so this is part two of the chapter 8 lecture in our textbook. So right now we are in talking about casting forms and how we get different types of castings. Specifically, we are referring right now to investment castings, or what's known as the lost wax casting method. Now, this has been around for thousands of years, and is still utilized today as well. So in the lost wax casting method, wax is molded, so and built up into patterns. So of course that wax is put into the shape of the desired steel part. Nice thing about wax is you get a nice smooth surface finish. You can either form wax in a variety of different ways as well. Now, at that point, so once we have that wax pattern, it gets covered in a ceramic slurry. That slurry is dried, so and then the wax is melted out, leaving the hollow ceramic shell. So we also can do the same thing with styrofoam. So where the molds are then heated and liquid metal is poured into the hollow cavities, the styrofoam patterns also gets the styrofoam also gets melted out and removed and used in place of wax as well. So both of those are valid ways to help us create these cast parts. So after the metal is poured into the investment casting, that metal cools, the shell is removed. So your parts have the exact same shape as the wax, and likewise the surface finish tends to be better with wax investment castings as opposed to the sand castings, just because the wax is a smoother, nicer finish overall. So generally, these parts are on what they call a sprue. So the sprue is part of the actual process to allow air holes or venting or even the pour. And the connection, especially if you're doing a cast of multiple parts. If you think about the sprue, probably the best case, if you've ever put together a plastic model or a model kit, you have all the pieces that you break off and take. Those pieces are being broken off of the sprue, or the plastic sprue in that case. But metal is the same thing in the same way there. So those parts are then cleaned up for machining or heat treating if there are any other processes that need to be done to it. So as well. Permanent mold casting obviously is used when the volume of parts dictates. So when we know that we're going to have certain types of production runs, then we can invest in the tooling to create more permanent molds for casting. And these molds can be made out of steel or any other type of oxidation resistant alloy. They are not disposable like the packed sand and ceramic shells. So graphite inserts there can be assembled inside these mold forms to help us get the desired shape as well. The steel mold itself is not touched by the molten steel poured into it. So oftentimes there are some type of material that goes in between there to help as a barrier as well. Of course, after solidifying, the mold is opened up to remove the casting as well. Centrifugal casting is a great way to make different types of pipes. We talked before about how you could roll pipe in sheet metal and then weld it. That gives you a little bit of a variance in the actual material, especially, and changes some of the properties, especially around the weld seam. So in this case, when we're doing centrifugal casting of pipe, it does give us a much, much better, more uniform composition throughout the entire pipe. And in general, these molds here, these rotating molds, are underground. So, and of course, they're rotating, which forces the liquid metal up against the inside of the mold. And then as it starts to cool down from the outside towards the center, it gives a nice uniform composition. Vertical axis centrifugal casting is kind of along the same line. The molten metal's poured into the spinning mold below the floor. The outer portions have very, very desirable improved properties, and there's lots of actual integrity to the different components there. So they generally have improved impact strength and improved toughness as well. So some of the reasons here for using cast steel. So obviously when we're casting parts, we're looking at the different shapes, and these shapes are not as easy to produce out of a sheet or plate. So if we were going to do that, machining time would have to be included, and that machine time and cost to cut the plate can be kind of high. So oftentimes a cast part is done to save on machining, or in parts where we say only need to machine certain areas. So outside of the part doesn't need to be touched, so we can just cast it as opposed to try to machine it out of straight bar. So your yield strength here in a casting is very similar to wrought steel. So unfortunately on a cast part, your impact strength, your ductility, that might be reduced. And of course on castings there is a coarser microstructure than on wrought steel itself. Obviously with cast parts, surface finish can be a deterrent. So if you do need a really high quality surface finish, that's all going to be depending on the actual mold itself. So that might be a consideration there, whether you use a mold and a cast part versus some of the other parts as well. We do have problems with a lot of castings, and when we have these problems, that's called a misrun. So foundries do a lot to try to avoid misruns. Again, remember we talked about the importance of getting and maintaining the temperature of the metal in the pour while it's still in the ladle. So if that pour does not flow properly, it's not necessarily going to fill the entire mold. So if it doesn't kind of get pulled through the mold, or depending on the temperature as it cools, you might also get voids inside the actual material as well. That's going to cause those castings to be scrapped. They're not, we don't lose that material. That material can be remelted and reused. However, you do lose a lot of production time. So obviously companies want to maintain this for their efficiencies and do better. And of course, if those particular parts and castings would get out to a customer, that also can kind of influence a company's reputation. Too many bad castings being sent to a customer can also cause companies to lose that customer where they go to somebody who can provide them with a better quality part. So keep that in mind there as well. In order to prevent that, of course, you've got to really maintain the metal temperature there in the ladle. And of course, we got to keep different types of metal oxides, what they call dross, from hitting and touching the molten metal surface or contaminating the actual liquid metal as well. Here's where we're talking about casting voids. So we get different pockets. So I've got some material in the lab that is some plastic that are a good example of this, where the inside of the actual material is hollow. So they didn't get a very good pour, and they made some bad material with that. So we want to make sure when we are casting parts that we're getting good castings and we don't have voids in the center. We get casting porosity. So as that is poured, so the gases in the solution, obviously oxygen and nitrogen, can cause bubbles. So we want to try to get that out. So, and porosity in these castings, I'm sure if anybody has machined sand castings or some different type of cast iron, sometimes you will see these bubbles that are in there. So, and that of course will cause rejected castings as well. So the foundries want to produce a good product. So companies' reputations are based on this. So as if you're going to work for a foundry, you do want to pay attention to this and talk with the more senior people on how they make sure that they are maintaining consistency and a good quality, reliable product as they're working on the shop floor. Here are some cast steel applications. So obviously some of these large parts here are cast, bearing housings, valve bodies, food processing equipment. So electronics, oil and gas industry uses these, transportation industry. In our area, probably one of the largest consumers, of course, of these. Well, actually two companies, both Mueller makes a lot of castings here, as well as Caterpillar. Caterpillar, especially for the very large parts, are using castings with them, as well as the next type of material that we're going to be talking about too, and that is, of course, forging. So I'm going to stop this video here. We'll come back for part 3 and talk about forging.